Module 23 Simple Linear Regression, Section 3 Mistakes to Avoid in Simple Linear Regression. So when r squared is low, the tendency is that, inherent tendency is that we conclude that there is no relationship between x and y. That kind of conclusion is totally wrong. Only that you can conclude is that there is no linear relationship between x and y. As you can clearly see in this diagram, there is no linear relationship for sure, but there is a relationship between x and y. As you can see that it is increasing, then decreasing, then again increasing, then decreasing. You see there is actually a non-linear relationship here, which can best explained by a sine wave perhaps, but it's not actually a linear equation. So you can never conclude that there is no relationship between x and y. It's always better to look at the dot plot first, the xy scatter plot first, before deciding whether to go for a linear regression or a non-linear regression, which we are going to explain in a later module. So do not smooth the data or use a rolling average before regression analysis. So that will invalidate, because it is actually the the rolling average is not the, you have to use the raw data first. So when x and y are intertwined, do not use a regression. So the graphing a change in the variable versus the initial value of that variable, that will lead to something called regression fallacy. So it will always be related, it's basically a fallacy, that whatever that the change that we are seeing, the regression that we are observing, that is basically spurious. It's artificial. It's not there. So you should know precisely which is x, that is control, and y, that is measured data. If you interchange this x and y, it will also change, of course, the regression line. So, and also you should decide it, and you should not trust the computer to decide. Please pick one, x for me and y for me. That is irrational. You have to decide which is x and which is y. So you should not merely look at the table values. Graph is more important. So it's always better to look at the graph to see that it's more or less Gaussian around the line. So if it is not Gaussian distribution around the line, then linear regression is incorrect. So in this case, you can see the 4 quadrant, only the top left is perfectly fine for a regression, while top right is non-linear for sure, and the left one is, there is some few outliers, and the right one is basically the bottom right one is probably a log normal. It doesn't look like a normal distribution at all. When the scatter increases as the y increases, do not use a standard unweighted linear regression. You have to go for a linear regression program that accounts for this variability. It is not homoscedasticity, but variability changes. It is invalidating the homoscedasticity or equality of variance across the line. So in that case, you have to go for a corrected version of the regression algorithm. You should never extrapolate your regression line beyond the data and make conclusions, as you can see in this funny cartoon. Yesterday I had no husband, today I have one, then tomorrow, day after tomorrow, and go on. Then after 1 month, you will be having 2 dozen husbands. So that makes no sense. So that kind of extrapolation, though it is inherent tendency for us to extrapolate the data beyond the line, but that actually makes no sense. You should never do that. And do not overinterpret the small p-value. You always have to look at the r squared value and the linear equation, rather than simply looking the p-value. The p-value is very easy to get a very extremely low p-value just by increasing the sample size drastically. So that actually makes no sense. As you can see in this diagram, this is very poor fit the linear equation, but still the p-value is extremely less, infinitesimal, because of the extreme sample size involved in. So x and y need to be in the same unit? No, it need not be in the same unit, because these two are two different variables. So it can be in different units as well. If x values are categories like gender, drug labels, etc., linear regression works only if the categories are rank ordered and equidistant. So it can be assigned as a sensible number. So the numerical representation in some way is needed before regression can be performed. Standard error of the slope is related to the 95% CI of the slope. It's not exactly same as SEM or standard error of mean. These two terms are quite different. Standard error of the regression line. If you interchange x and y, or that means the swap the values, regression line would be different. So you are going to get an altogether regression line if you swap these values together. R squared will be 0 if the line is horizontal, but R square can never be negative. You know, R square is always between 0 and 1. So it is advantageous to have more than one y values for each x, so that the technical error can be avoided. So precision can be increased, the accuracy can be increased by having more technical replicates to your measurement. So you can determine the slope with more precision and homoscedasticity. So it's always better to have more data points, the wide data points. Regression is quite often used in artificial intelligence, using machine learning to train the regression model that predict, for example, from the real day life. You can say that Amazon product recommendation based on the user's prior online behavior. So like whatever the things that you bought earlier, for example, if you bought a number of cat related, the Whiskas or the pedigree for the cat food, then they will they will recommend more and more cat related or pet related things to you. So these are nothing but a regression model that is being used by the Amazon's software algorithm. The number of traffic accidents based on the road conditions and the speed limit. So the selling price of the real estate based on its location, size and the condition, so you can decide, the model can decide the optimal selling price rather than going for too astronomical figure where nobody will buy, or going for a very small thing which you are the loser. So it can predict the optimum selling price by a proper regression method. Learning to avoid overfitting and choosing a model that is not too restricted or not too flexible is one of the most essential skills of a data scientist. So you need to find a model. Model is nothing but a mathematical equation which is not too restricted and not too flexible. So overfitting is a very important issue with machine learning and artificial intelligence, where a model performs very well on the training data, but it doesn't generalize with the real world data or unseen data. When it gives, then the model is performing so poorly. This is all because of the overfitting, and it occurs when a model is extremely complex, with lots of parameters, having so many parameters relative to the number of observations. So that is the problem with the overfitting. But this is one of my favorite quote from the Einstein. It's the model should be as simple as possible, but not more so. So what does that mean? You need a nice fitting model, but it should be quite simple but not simpler. It shouldn't fit too strong, it shouldn't be too weak. It should be just right, just like the Swedish word lagom say. It's just the moderate of everything is just fine. That is the Swedish philosophy. So Occam's razor concept, the parsimony concept is also same. So providing everything being equal, the simplest solution seems to be the most elegant solution. So rather than going for more complicated solutions, go with the simplest solution that explains your data very well. That is the Occam's razor principle, or the principle of maximum parsimony. So every p-value can also be viewed as a result of this model fit, comparing the fit of the null hypothesis with the fit of a more general alternative hypothesis. So that is another way to interpret the p-value. So fit of the null hypothesis versus more generalized alternative hypothesis, which fit is fitting well. So p-value answers to the question, if the null hypothesis were true, what is the chance that the data would fit alternative hypothesis so much better? So that is how. So if it's extremely low, the chance is it's very less. So if you get a very low p-value, that means that there is a low chance that the data will fit alternative model if the null hypothesis were true. So therefore we reject the null hypothesis. So that is how to interpret the p-value in light of this regression, so the model fitting. So of course there are other kinds of regression methods as well. It's not just a linear regression, which is the simplest regression, is the simple linear regression. So non-linear regression is another important thing, which is like linear regression. Non-linear regression fits a non-linear models with the data. So it is not simple y equal mx plus c, but more more complicated or little bit tricky, like quadratic or cubic equations. polynomial equations or much more complicated, equations which is non-linear can be fit into the nonlinear regression method. So multiple or multivariable regression, so when one dependent continuous variable is affected by two or more independent variable, you can use this kind of multiple regression that we are explaining in module number 24. So the earlier one, the nonlinear regression, will also be covered in module number 24. Logistic regression is when dependent variable is binary, like male or female. So that is also a subset of a multiple regression that is called logistic regression, that we are going to explain in the module number 24. Proportional hazards regression, when the dependent variable is survival time. So that is another type of the regression method. So all these are different kinds of regression methods that you can choose from. So in summary, when the R squared is low, we should not conclude that there is no relationship between x and y. So you can only say that there is no linear relationship. The relationship might not be linear. There might be some relationship, obvious relationship also, which is not linear. So when x and y are intertwined, do not use the regression. So regression is the powerhouse of the artificial intelligence and machine learning. Thanks for watching.